In this lecture, we'll discuss about the key electric vehicle technologies. If you see, following are the main electric vehicle technologies. First, the vehicle body design. Second, electric propulsion technologies, energy sources technology, energy management, and electric vehicle system optimization. We'll discuss these key EV technologies briefly. The first is the electric vehicle body design. The body design can be a conversion type, that is the conversion electric vehicle. As the name indicates, it is converted from the existing vehicles, that is the IC engine vehicles. Thus, the engine and associated equipment of the existing vehicle, IC engine vehicle are replaced by electric motor, power converter, and battery. So, IC engine is removed from the existing vehicle and electric component are installed and it is just converted into electrical vehicle. Now this is one of the simple option one can see, and it is rather economic as you are using the existing vehicle body and adjusting the electrical components to make it electric vehicle. So it offers economy for small production as existing IC engine vehicle chassis we are using. Now, one of the problem in most of the conversions, this conversion from the existing vehicle to electric vehicle, the converted electric vehicle suffers from the large weight or increased curb weight and unbalanced weight distribution. So obviously it will suffer with the efficiency of the vehicle, but it is one of the economic when you go for a smaller production level. Second type of body design called as a purpose-built electric vehicle. Also, it is ground-up design. So vehicle is designed from the scratch. Each and every component is designed as per the requirement, as per the required design, and vehicle is built. So this allows a greater flexibility. So we can design as per our wish, as per our requirement, and we can coordinate various components, integrate various electric vehicle subsystems so that they can work together. And most important, we can design a most efficient electric vehicle. Now, the overall performance will be very good, mostly range, gradability, acceleration, and top speed can be improved. So range of the vehicle, obviously, we can design in the best possible way. We can add the required components such as electric motor. We can design its place, its location in the vehicle. We can place the batteries at proper locations because it is from the scratch design. We can manage the weight also. We can place the component at appropriate places. We can adjust, or we can design the top speed and acceleration as per our requirements. So this purpose-built vehicle save the weight, as a reduced weight is there. Whatever the coefficients, that is a drag coefficient, we can reduce. Rolling resistance, we can reduce. So these are the opposing forces to the vehicle when vehicle is moving on the road. So there is road and tire resistance. So that is the rolling resistance. There is drag because of the force of the air, opposing force of the air. So by suitably designing the vehicle body, which will have less opposition to the airflow that can be designed. So aerodynamics can be suitably designed when you are designing the vehicle for your electric vehicle purpose. But there are two options as discussed. We can either convert the existing vehicle, ICE engine vehicle into electric vehicle, or we can at all build a new vehicle, which is the purpose built vehicle. Now, second technology is the electric propulsion. Now here propulsion means to give the required torque to the vehicle to propel the vehicle. So this system converts electrical energy into mechanical energy so that the vehicle will move, and it has to overcome also aerodynamic drag, rolling resistance, and kinetic resistance. So we have to move the vehicle against these opposing forces, and this can be done by the electric propulsion system, that is nothing but a motor drive system, transmission device, and wheels. So this is the these are the major components of the electric propulsion system, that is motor drive, transmission device, and wheels. If you see the major requirements of the electric vehicle motor drive are high instant power and high power density. So the design drive should give high instant power, quick instant power, and required power density. So high power density will basically reduce the size of the drive. High torque at low speeds for starting and climbing, as well as high speed at low torque for cruising. So these are the main requirement. So whenever the vehicle is at start, it has to overcome the inertia and it should start the vehicle and give motion. So it should have high starting torque because initially speed is low, and reverse when speed is high, obviously then it should produce the low torque. So these similar requirements or similar characteristics are obtained in IC engine vehicle by using the gear arrangements. So here the electric motor drive system should provide these characteristics. The next requirement is wide speed range including constant torque and constant power regions. So it should provide a wide range of speed from low speed to high speed, and also constant torque and constant power region. So there are characteristics, torque speed characteristics, and it should give the better torque speed characteristics. Fast torque response, so it should quickly give the required torque. Suppose if you want to suddenly a torque is required, such as you have to overtake a vehicle, you have to take overtake, then suddenly you require a torque as well as speed has to be increased. So in that case, it should have a quick response. High efficiency over wide speed and torque ranges. Very, very important. So whenever in a system is there, efficiency has to be very good. So the motor drive system or the transmission system, it should have very high efficiency over all speed and all torque range. Another thing is efficiency of regenerative braking. It should be high efficiency. As one of the advantage of this electric vehicle is regenerative braking. In IC engine system, the braking is only the mechanical braking where energy is wasted in the form of heat and vehicle stops. But in electric vehicle, we can generate the electricity, that is regeneration, while braking by using the electrical braking. And during that also, whatever energy is recovered, that should be larger or that should be maximum. And next is high reliability and robustness for various vehicle operating conditions. So the vehicle design uh, and the components such that motor drive, transmission device, all should be reliable. They should work properly and they should be robust, sturdy, compact. They should have good life for all vehicle operating conditions because vehicle will operate at various road conditions. It will not always operate on a smooth road. It may have rough road conditions. Torque may be different, but for every condition, it should give the better options. Next is the energy sources technology. Now, energy sources, there are different energy sources are available. One energy source we know always, we are familiar about the batteries. So battery is one of the energy source. Similarly, there may be supercapacitor, there may be flywheel. So all these energy sources should fulfill some requirements or desirable characteristics. So they should have high specific energy. If suppose we are taking a battery, it should have high specific energy and high energy density. Now, specific energy, basically energy per unit mass. So whenever we are taking any energy source, it should have larger energy in a smaller mass. And similarly, energy density, energy stored per unit volume, that is the energy density. If you see here, so specific energy, it is given here energy per unit mass. Energy density, it is given here energy stored per unit volume. Also, in the similar way for the energy, it should have power also, high specific power and power density. So specific power means power per unit mass. So in a smaller weight, it should have larger power. Also, in a smaller volume, it should provide a larger power. So this is a power density. Another, fast charging and deep discharging capacities. So whenever any energy source used for electric vehicle, that is the battery, for example, it should have fast charging and deep discharging capacities. To save the charging time, it should be a fast charging. So it is possible to charge it with a fast charger and it should accommodate this charging in a faster way without any problem, without any excessive heating and damage to the system. Also, once it is fully charged, it should provide the deep discharge. Deep discharge means it should provide the maximum discharging power. You can discharge it to the full extent. Many times, if you discharge the battery to full extent, life of the battery is reduced and the device almost get, you can say, reduced life and damage. So battery should not lose its life. So if suppose it is reduced to up to 10%, that is up to 95%, 90%. So it should allow this deep discharge. Then next is long cycle and service lives. So as discussed, it should provide long cycles, that is charge discharge cycle for long distance. Once you charge, it should remain it should provide the power for a long time. So it's a discharging cycle. Also, the life should be longer. So that replacement should not be frequent for any energy source. Another is low self-discharging rate, and high charging efficiency. Now, once we discharge the battery, it is supplying power or energy to the load. Now, self-discharge is whenever the battery is not used, it is not connected to any load, it is just idle. Then also some energy loss is there, some small discharge is there called as a self-discharge in the idle condition. Now this discharge is because of the inherent chemical reactions, chemical property of the battery. So low self-discharge has to be reduced. It should be, sorry, self-discharge has to be very, very low. And high charging efficiency. Obviously, during charging also, it should provide the high efficiency. Another important thing when we are using any energy source, it should be safe. There should not be any hazard. It should not be explosive, for example, and it should be cost effective. Another important characteristics or feature the energy source should have, it should have low maintenance, or expected it should be maintenance free. And considering our EV requirement, it should be environment friendly, and the source should be recyclable. So these are few important characteristics energy sources should possess. And we have seen the energy source may be a battery, it may be a flywheel, it may be a supercapacitor, or energy source can be also a fuel cell. So these four type of energy sources we can use for electric vehicle applications in combinations with mostly battery, and all energy sources which we select, they should possess these desirable properties. Now the another technology which is required in electrical vehicle is the energy management technology. Now, if we see, there should be good management of the energy because battery is the energy source, and this battery, once it is charged, it is on board on the vehicle. Now, if we use this energy very efficiently by managing it properly, the vehicle can travel for a long distance. So energy management is very, very important. Now, we call it also intelligent energy management system. Now, what are the functions of this energy management system? Energy management system should be designed such that it should optimize the system energy flow in an appropriate way or in an optimal way, in the best possible way. So all energy flow, suppose energy flowing to the motor, energy is flowing to the control circuit, energy is flowing to the auxiliary devices. So it should be flow properly and it should optimize it. The energy management system or energy management circuit should predict the remaining available energy and residual driving range. So it should give the indications also, and it should predict, it should calculate appropriately and show it how much energy is available into the battery, how long the vehicle will travel with this remaining energy, so that the driver can get the best idea how long the vehicle will travel before it requires the charging. Next, the energy management system should suggest the more efficient driving behavior by itself. So, which is the best driving behavior? When to switch, suppose it is a hybrid, when to switch to the AV mode, electrical mode, when to switch the IC engine mode. So this decisions, they should be provided efficient behavior. To direct regenerative energy from braking to receive energy sources like batteries. So it should provide best management for the regenerative braking also, and also it should utilize the energy from the battery appropriately. To model temperature control in response to external climate. So energy management system should control the temperature considering the climatic condition or external climatic conditions. It should maintain properly. It should keep the comfort, as well as you should check the energy should be optimally utilized by maintaining this temperature. Now, it should propose a suitable battery charging algorithm. So while charging the battery also, energy management system should suitably check that what is the type of battery, what is the rate of charging, and based on that it should provide a suitable algorithm, suitable way so that battery will charge appropriately. Battery should charge faster but without affecting the life of the battery and in a safer way. Next, to analyze the operation history of the energy sources, example battery. So the energy management system should keep the operation history of the vehicle, operation history of the various energy parameters, so that one can go through it and check the energy consumption, energy utilization. And finally, to diagnose any incorrect operation or defective components of the energy source. So always it should check any problems there in the operation or there is some defects into the components, and it should indicate it so that corrective actions will be taken and damage or loss of the device can be avoided. So overall, energy management is an intelligent energy management system, and it optimize all the energy to increase the range of the vehicle. Next technology is the system optimization. For system optimization, basically it is a system level simulation and optimization for electrical vehicle. As we have to optimize the electric vehicle system, this optimized system should check and analyze interactions among various subsystems, as these interactions affect the performance of electrical vehicle, and these interactions should be properly analyzed. System voltage for electrical vehicle design, battery weight, motor drive voltage, current ratings, acceleration performance, driving range, and safety. So these are the important parameters as far as we consider the electric vehicle optimization, and they should be optimized on the system level, and they should be best designed. So it should provide the best AV voltage, it should provide the best battery weight considering the requirement of the electric vehicle. It should provide the best drive voltage, current ratings. So optimization should be done to get these best possible parameters, their values, their ratings. It should also, the design should be done such that it will provide the best driving range with this optimization. To increase the driving range, multiple energy sources may be adopted for modern electrical vehicles. So the system optimization or the system level simulation and optimization should be done so that we can get best driving range using multiple energy sources. Now this optimization system will provide the way to use multiple energy sources. For example, battery and supercapacitor. This is two multiple sources, or battery and flywheel, or we can have a combination of these two so that the driving range can be increased, and that will be again a cost effective solution. So optimization should provide this multiple sources and its driving range. Many times we are going for this hybridization. Now, combination and hybridization ratio should be optimized on the basis of vehicle performance and cost. So in the hybridization ratio, we mostly check what percentage of the contribution by electrical source, and suppose it is a hybrid electrical vehicle, there is also IC engine. So what percentage of contribution will be better when we add electrical propulsion over the total contribution, that is by electric propulsion and IC engine propulsion. So this hybridization should be properly done by using the optimization. We see that electric vehicles generally adopt fixed gearing. The gear ratio can greatly affect the vehicle performance and drive's ability. So optimization should provide this best possible gear ratios so that we can get a good drivability. An optimal ratio should be determined through iterative optimization under different driving profiles. In the system optimization, we have seen various parameters can be optimized to get the best vehicle design in terms of battery weight, motor drive voltage, current rating, acceleration, driving range, safety, multiple sources to be adopted, which is the best optimization ratio. In addition to this, all these parameters also should be optimized considering the different driving profiles, say city driving, say highway driving, say continuous uphill, downhill. So every road conditions or driving profiles should be considered while going for the simulation and optimization, which will be done for the electric vehicle. So we have seen here 5 electric vehicle technologies, that is body design, electric propulsion, energy sources, energy management, and system optimization. In body design, we have seen it can be conversion electrical vehicle or purpose-built electrical vehicle. In electric propulsion, it is mostly the electric drive, that is motor and drive system. There may be various types of electrical drive. We can see in a separate lecture. There is energy sources technology, that is a battery, flywheel, fuel cell. Also, energy management technology will take care of optimizing the energy of the vehicle so that we can get the good range of the vehicle. And lastly, the system optimization, where we go for the optimization of the various parameters, various components of the electrical vehicle so that we can get the best vehicle design, considering the efficiency, considering the reliability, considering the cost, and considering the range of the electrical vehicle.